Hello everyone, this is a video lecture for Calculus 1, section 3.9, Related Rates. And here we go, derivatives, again. 39002, I got a is equal to pi r squared. And there's every one of these is a word problem. I'm just trying to get through with what needs to be done. And they say, what's your derivative? And then we have this guy here. And this is part A answer. There's a part B here in a second, but part A is, hey, what's the derivative? Well, it's 2 pi r. Cool. That was easy. And then it says the radius is going to increase by a positive 2 meters per second when the radius itself is equal to 32 meters. So then part B is go ahead and find the rate of change then. So then I would get 2 pi times my r, which is the 32, and then times the derivative, which is a positive 2, and you can do it, and it's 128 pi. Okay, what is going on here? Like, it's kind of weird to see this dAdt, drdt kind of stuff, and we kind of saw this with the last question in the last section a little bit. What they're trying to say is that we have a derivative. I mean, you could go ahead and just say that's a prime. So I'm going to take the derivative here, and so the 2 comes down, 2 pi r, right? Easy. But now, complicated inside, I guess, you could say like here, and so you have an r prime. You know how we do this with implicit derivatives? We would have a y. What's the derivative of that? Would be like 1y prime. We've done this a lot with ln of y as 1 over y prime. So you got to always include that flag thing, I guess you can call it, and that's fine. This is important here, but now they're trying to use the Leibniz notation to do dAdt, and then you put all your stuff here, and then you got drdt. Again, this is just r prime, a prime. That's all it is. But when they say divided by dt, they're getting at that there's a time element in here, and that's why we got seconds in particular. I don't know. You can just say it's a regular derivative. It'll be fine. So, next question. This is actually a pretty classic question. There's another one just like it here in just a few minutes. But we have a spotlight on the floor, and then we have a man standing in front of it, and the spotlight is going to hit him and cast a shadow here onto the wall. Okay, so that's the shadow on the wall. Okay, cool. Great, awesome shadow. So the height of the shadow is h, and we have the distance that he is from the light is 12 minus x, because at this particular x value, they're going to say that we have an x equal to 4. Now this is that's a number that we'll plug in later, but it's not actually... like when I'm solving, I guess you could say, I don't actually say 4 and then start taking derivatives. This is at the very end. This is the last step, okay? They say that the man is walking towards the wall at a positive... I'm not going to put a positive. I'm just going to say a 1.9 meters per second or something like that. That's his rate. And the man himself is 2 meters high. That's a whole lot going on here. So ultimately, what they're wanting is what is h prime? What's my dHdt? How much is the height of the shadow increasing or decreasing? Well, let's think about this for a second. As he's walking towards the shadow should actually be getting smaller, because eventually when he's standing right at the wall and you got the spotlight, right? The shadow would be basically as big as he is. And it was bigger, okay? It was up here, but now it's much smaller. So I'm definitely going to have a negative value here, okay? This is decreasing. But because they use the word decreasing in the language of trying to find dHdt and all that kind of stuff, we probably will end up giving them the absolute value of what's going on, okay? In fact, I'm going to look ahead, and yes, although it's going to be a negative answer, you need to put a positive in there because they've already stated the fact that it's decreasing. Whatever. So how do we accomplish this task, right? This is so strange out of nowhere. And there's probably a couple one of them, but I'm going to do similar triangles. This is definitely one of the easier versions on how to make this thing work. So we've got two triangles going on. We got my 2, and I got an h, and they're both the same theta, so it doesn't actually modify anything. This right here is 12 minus x, and this apparently is an x. And we're supposed to figure out the similar triangle thing. So this triangle here, the smaller one, would then be 2 is to 12 minus x as, and now I'm going to do the bigger triangle, as h is to 12 minus x plus x. So like this one and this one to make a full distance there. Well, one thing, the x's there cancel. Okay, and that's fine. This is actually not very fun because the x is in the bottom, so I'm going to just rewrite this by flipping it. That is totally fine with these similar triangle fraction stuffs. You could do the algebra to get there, but this is just going to be more friendly to you. And now that my x is in the top, I don't even like that. Here, pause on all that. Because we still got an h, and we got to figure out h prime, right? So that didn't help. Rather, let's multiply these to the other side so that we can kind of get like a all-in-one, no more fraction thing. So 24 is equal to h times 12 minus x. And I'm going to distribute this guy. So we got 12h minus xh. Okay. Cool. Well, this is going to be my formula that I start taking derivatives and stuff of. Okay, so let me just rewrite it. 12h minus xh is equal to 24. Okay, so now I want to find the derivative, and this is going to be implicit, so that's okay. I got 12h prime minus, and this is product rule, so derivative of the first is going to be an x prime, and then we got an h, and this minus sign distributes to both of them. I'll do that here in a second. So I leave the x alone, and then I got an h prime, and then equals 0. Now you could do h prime, whatever primes, it's up to you. What they really want you to do is dh dt. I'm going to just simplify this a little bit here. dx dt, distribute, dh dt. That's really what they're wanting you to do. But that's the same thing, so it doesn't really change anything. I could move this to the other side, and then I could factor out my dh dt to the front, getting a 12 minus x left over. When you move this over, it's a positive now, h dx dt. Okay, so I want to solve for dh dt. That's what they're actually wanting. So I'm going to divide this to the other side. dh dt is equal to h over 12 minus x, and then times dx dt. So this is my formula here, I guess you can say. Okay, so cool. What I want to do is start plugging in the constants that I know. The problem is that I don't know what h is. I don't know what h is. They never told me. They just said what x was right here. They said x is 4. Figured it out. Well, what's actually going on is that we have a 12 right here, and this is a 2 for this 12 minus x. So then this is actually just 12 if you do the math here. And so then what's this similar triangle here? Let's just kind of solve that right quick if that's okay. So this is a 2, and if I'm plugging in a 4 right here, this side on over here is going to be an 8. So then I'm saying that this whole thing is a 12, and I want to find my h. So 8 is to 2 as 12 is to h. And you can flip things around. Basically, here we got 4h is equal to 12, divide, and h equals 3. Does that make sense? Yes, that's fine, because this is 2. This is 2, so then this is going to be a 3. And I'm going to plug that in down here. I'll just start over. So 3 divided by 12 minus 4 was my x. And then dx dt, if you remember, is this 1.9. But my x is getting smaller, right? X is going to be this distance here. And eventually x becomes a 0. So this is a negative 1.9. Okay, I did my notes a little bit differently, and so what I want to do is just verify that I'm going to do this right. So 3/8 times 1.9, and I got the same answer, so negative 0.7125. But they're wanting the positive as their actual answer, so dHdt, because they use the word decreasing. How much is it decreasing by? So they're already including a negative, essentially. Okay? There you go. That was a classic problem. Let's do another one. So I have a ton of words here. I cannot copy them all. So here we go. The length of a rectangle is increasing at a rate of 7 centimeters. So I'm going to call length prime is increasing positive 7 centimeters. Okay. And the width is increasing at a rate of positive 3 centimeters per second, by the way, per second. When the length is equal to 9 and the width is equal to 4 centimeters, how fast is the area increasing? So A prime is equal to what? All right, well, A is equal to length times width, right? Area is length times width. And so then I want A prime, then product rule, L prime W plus LW prime. And thankfully we have all these guys, right? They're just literally up here. So 7, we got a 4, we got a 9, and we got a 3. And so we got, what, 28, and we got a 27, and so then we got 40, 50, 55. Should just look at my notes. Centimeters squared per second, because it's area, it's centimeters squared. Okay. More words. Everything's a word problem here. 39007. So, a cylindrical tank, okay, and it has a radius of 5 meters. So this is a big old tank. And it's filled with water. So we're inputting water at a rate of positive 2 meters cubed per minute. Okay, so 2 cubic meters per minute. How fast is the height of the water increasing? So we have the height of the water here. Just kind of making up some water. And it's going to be increasing. So this is height, and we're filling it with water here at the top, with like a hose or something. And that water is going to come out. It's going to come up. And so they're saying, how fast is it increasing? So H prime equals what? dH dt is equal to what? Either way there. So, okay, we're filling this thing up, and so we want a volume of water. So volume of a cylinder is pi r squared h. Notice the circle, but I'm adding a dimension to it. And so one thing that I know is that my volume currently, which I think I might need. Oh, no. Yeah. Pause for a second. This is good. What is the one constant out of all this thing? It's not the height. I guess we have a rate, but I can't plug that in. My radius is 5. And so I can actually plug that in right now without doing any other math. Makes it a little bit easier. Okay. So V prime, this is going to be dV dt, is equal to, and you take a derivative right here of this guy. And so 25 pi, and the h goes to dH dt, okay? Or just h prime. We have dV dt, it's the rate. See how that's a volume over time? And so then this would just be a 2. And this is 25 pi. And then dH dt is what I'm looking for. But h prime if you want, it's whatever. So divide this to the other side, and that's your answer. H prime dH dt is 2 over 25 pi. Okay. Meters per minute. Okay. 39004. the radius of a sphere is increasing. Let's draw a sphere. Okay, there's your sphere. It's like a ball. The radius is increasing. So my radius is just to any point out there. All of these are your radii. Radius is increasing at a rate of positive 4 millimeters per second. How fast is the volume increasing? When the diameter is equal to 40 millimeters. Diameter, pause. This guy right here is 2r. So my regular r is 20. Golly gosh, how many times have I gotten this wrong because I didn't do something simple like that? Okay? Be on guard. Watch out for these simple words. So what's the volume of a sphere is 4/3 pi r cubed. Did you know that? So there actually are a couple volume formulas that I know. The cylinder one is super easy, but the volume one of a sphere is a little weird. I'd say that you could memorize this guy. This is not something too hard. I'm going to ask, what's the volume of a pyramid? I don't know that one. What's the volume of a prism, a rectangular prism, like a box? Yeah, I could do that one. Length times width times height. So there's some that you can memorize. This one's a moderately easy one. So there you go. So now that we have it, let's find some derivatives. dv dt is equal to, I got 4/3 pi, and then I have the 3 come down. Now it's an r squared dr dt. Okay. Well, I have my r is a 20. I have my r prime is a 4. Find dv dt. So 4/3 pi, 3 times 20 squared times 4. Calculator, calculator, calculator. And I got 64,000 pi. And this is going to be millimeters cubed per second. Okay. 39017. So there's always word problems here. Oh my gosh. Just so many word problems. And I'm happy that we're doing them, kind of. So we have 2 cars, and they start at the same point. So they're going to race. Here's my 2 cars. Here, this guy here, he's got a cool little fender thing at the back. You know, this one here's got like a paint job with a stripe down the side. All right, there we go. So we're here at the starting line of a race. Let's do some checkered action. Awesome, that looks great. Great checkered action. Okay, so we're here at the start of a race. Oh, I had to read the rest of it. Well, my race is one goes south. Okay, whatever. So we have 2 different cars. One is going to travel south, and the other car is going to travel west. I just wait to the end of the problem. I need to read it a little bit more. I just saw the 2 cars and thought it was going to be a race. My bad. Okay, so the one goes south is going at 48 miles an hour. I'm going to put miles per hour, but yeah. And the other going west is going 20 miles per hour. What is the rate of distance between them, or is increasing at 3 hours? Okay, so here's the thing. This distance between them here is what we're trying to figure out, I guess you could say. Let's do Pythagorean theorem. So I've got, let's call this x and let's call this y. Pretty simple, I guess. And so x squared plus y squared is equal to d squared, distance between them, r squared, wherever you want to call it. And I'm going to start by trying to find some derivatives. So 2x dx dt plus 2y dy dt is equal to 2d dd dt dt dt. It happens. It happens. That's just calculus right there for you. No, it's dd dt. I'm sorry. It's dd dt. There we go. Whatever. Okay. Weird, but that'll work. Okay. Doesn't this look like the implicit flag method that we were talking about back a couple sections ago, when I would put my dx and my dy and then blah, blah, blah. Same thing. It's the same thing. And so you can now see why I'm teaching you different methods to do those derivatives. Okay, so this here is going to be my y prime. This is going to be my x prime. And I'm going to ask you, are these positive or negative? And you're thinking, oh, they're both going negative. Well, no. They're both making the distance increase. So this is more x and more y, so positive and positive. So you're going to have a positive 20 here. You're going to have a positive 48 here. And what they're wanting is the dt. This is the goal that we're trying to find. Now, they said, I said it really quickly. It says at t equals 3 hours. Remember, these are miles per hour. So then I'm actually going to say 20 times 3 is 60. And over here, we got 48 times 3 is, I got to turn the page here. I guess I could just use the calculator because that's pretty easy too. Apparently, I actually did not do it on my notes here. So 48 times 3 is 144. I should have been able to do that, but that's okay. 144. Okay, so we got my x and my y. And so now I can plug those guys in. So I got 60 and 144. My problem now is, what is my distance? And so I'd have to plug them in here to actually find that. So that would be a 60 squared plus a 144 squared is equal to d squared. So square root both sides, obviously. And let's get at it. So 60 squared plus 144 squared. And then I'm going to square root that thing. And I got 156. And so that's going to go right here, 156. I'm going to take these, obviously, and divide them to the other side. dt, d prime, whatever you want to call it. My answer, math calculator, is 52 miles per hour. There you go. Again, that's a rate of change. I have 2 more problems left, and this next one is a classic problem, and it is so easy to mess up. And so I really hope that I don't mess it up, because I'm trying to be a good teacher here, obviously. So we have a light post that is 15 feet tall, okay? We have a man standing over here, and the light is casting a shadow onto the ground over here. So this will be his shadow. There you go. So there's a shadow. And the man is walking away. He's walking away from us at positive 5 feet per second, I think. Something like that. And the man is currently 30 feet away from the lamppost, and the man is 6 foot tall. And there we go. So, what are they asking for? They say, how fast is the tip of the shadow? So, how fast is the tip of the shadow moving, increasing? Right here, they want to know what this thing is going to be. So as he keeps moving, it looks like the shadow is going to be bigger, bigger, bigger. Again, if he's right on the lamppost, like he's standing right beneath it here, the shadow is just going to be like kind of small. And so it's going to make the shadow bigger, bigger, bigger the more he walks. So he's walking away. How much is that shadow going to be increasing? Exactly when, and this is, I'm going to say this is x equal to 30, okay? So this is typically an x. I'm going to get rid of this so that we can see that he's actually moving. But at 30, we're going to find out what's going on, okay? Wow. Well, similar triangles again. So I have the same style as what we've already seen. So this is a 6, this is a 15. This is an X. And what is this guy right here? I'm going to label it as S. Now, I know my S and 5s look kind of similar, so I'm going to try to do that, okay? A little snaky thing. So that'll be my S. This right here is my shadow, is my S, okay? And so now I can do some similar triangles. I'm going to do 6 is to S as 15 is to X plus S, okay? Again, I don't like it that way. I'm going to just multiply them to the other side just to make it quicker. So 6x plus 6s is equal to 15s. I can minus the 6s on both sides, leaving me with 9s. So that's my formula, and that's pretty basic. Now what we're wanting to do now is find the derivative. And so I got 6x prime is equal to 9s prime. Was that it? I guess. Okay, whatever. dx dt's, whatever. Well, we know that this right here is a 5. And I'm wondering, is it a positive 5 or negative 5? Well, if he's walking this way here, it is a positive because he's making the x get bigger. So that's going to be a positive 5. And my shadow is going to be a bigger too. I guess what we're trying to find is the ds dt. So I could divide this to the other side. ds dt is equal to, I got what, 30 over 9? Which ends up being 10 over 3. Notice I did not box it in. So, how fast is the tip of the shadow? The tip of the shadow, not just the length of the shadow. This is ds dt, but this is the length of the shadow. We're wanting to know the tip. And you're saying, well, is that different? Well, yes. The tip is how far it's going out, I guess you could say. How fast is it going? Versus how fast is it increasing the, I don't know. Blah, blah, blah. This is just a length thing, and we have to figure out this tip. Well, the thing is, we have to remember is that the man is walking, okay? And when he's walking here, his shadow is right beneath him going outwards, right? So if he's walking this way at positive 5, then the shadow tip is also moving at a positive 5. And the length is increasing by this 10/3. So what we're going to have to do is the 10/3, which is the length of the shadow, plus the man actually walking, the 5, which ends up being 25 over 3 feet per second. That's your final answer. I know it's really weird because wherever he travels, the tip of the shadow is going to travel right alongside him, okay? But then again, we've already discovered that it's not like just the sun coming down from the top here where the shadow is always going to be the same regardless of how far he walks this way. Instead, it's based off of light, and so the length is changing and his position is changing. See the things that we have to do to get by, to pass a calculus class, to say that we've got it done, to get a degree. All right, last question. It's a gravel problem. Gravel is dumped from a conveyor at a rate of 30 cubic feet per minute. So what they're getting at is, there might be a picture of it, but they're getting at a cone, and so they're dumping this gravel here, and it makes a big cone. Surely you've seen that sometime in your life. Apparently h is the height, but it's also the diameter. So it makes a cone where the base diameter and the height are equal. So they say that in the problem. And then this means that my radius is equal to h over 2. So keep that in mind as we keep going. So my radius is a little different. How fast is the height increasing when the pile is 5 feet high? So h is equal to 5. They want dh dt. Okay. What? So remember how I said what's the volume of a pyramid and I don't know? But what's the volume of a cone? And it's this guy. So this is the volume of a cone. Now, I can't always remember that, but if I thought about it long enough, I'd probably give you a rough answer that was pretty close. Some things that I do know is that it's all based off the height. And so that radius here, I can change it to be h over 2. And so that's actually going to be 1/8 pi h to the 4th over 3. And we can do a little bit more math. So that's pi h to the 4th all over 24, I believe. I didn't do that in my notes, but okay. This is my volume. All right, so now V prime. We have a V prime, by the way. They gave it to me. Is the conveyor... Oh, they didn't. I didn't write it. Sorry. It's positive 30 cubic feet per minute. So that's my V prime right here. So we'll use that here in a second. V prime is equal to my derivative here. Pi over 24 can come to the front. And then I got 4h cubed dh dt. Again, the h prime either way. Why did I say dh dh? It's dh dt. Okay. Cool. Well, I can plug all this stuff in. So I got a positive 30, pi over 24, 4, and the height they had said specifically was a 5 at that particular moment, cubed. And then dh dt is what we're trying to solve for. All this is a number. Move it over to the other side. We'll get a crazy long decimal, and it's 1.527887. And that's feet per minute. I don't know why I was trying to say second. Minute. There you go. Cool. That's it. We're done. Done with this section. Whew. Thank you very much, and have a great day.